Hey guys, what's up? Welcome back to another excitingly simple tutorial. Today we're talking about actives and passives. Um, I don't know, maybe you have sometimes wanted to make a simulation or an animation if you have not experienced dynamics yet. Maybe you've wanted to do a simulation where where a sphere would the typical bouncing ball animation that you would animate it going down, then up, then down, then up, so on and so forth. Well, you are not constrained to having to animate that. You can actually do it with dynamics. In Maya, we have a dynamics menu right here, and there are on the dynamics menu. We're going to talk about a little bit about actives and passives and fields. In real life, there are everything is dynamic. Things behave with gravity and wind, and there's damping and friction, all that stuff. In Maya, we can pretty much achieve the same effects. So, for example, if you have, let's say, this floor, and that let's call that bowling ball, and you had this floor. Then and let's actually delete the history for both. Edit, delete by type history. There we go. So we got a bowling ball and a feet and a floor. Well, maybe you want your bowling ball to go down and bounce a little bit on that floor and come to a rest. Well, you can do that by having actives and passives. And in that case, this guy would be an active and this would be a passive. And I'm just gonna make the example really quick and then talk a little bit about it. So I'm just gonna go ahead and say create active and create passive, and then give this some gravity. So let's increase this to 9,000. So we would have our little sphere there come down and collide. So that is a basic example here of actives and passives. But let's go ahead and talk a little bit about it. So as I said, there are two types. There are actives and there are passives. So let's start by making a polyplane. Create polygon plane. Now I'm going to reset my settings here. So when you make a polyplane, that would be what you get. One thing to keep in mind when you're doing dynamics is it's based on real world dimensions, and it's based on the metric system. So if you, for example, gravity has a 9.8 meters per second acceleration. So that in Maya terms would mean that in 1 second it would move 9.8 units if it's set to 9.8, and by default a field gravity will have that. So the point here being is that it's about real world dimensions, so that you can be a little bit more accurate on your simulations. So we don't. Let's just go ahead and scale this floor to 30 units. So that'll be like a 30 by 30 meter type of floor. And let's go ahead and make ourselves. Let's make it a polycube and move it up. And this has a meter by a meter. So let's just put it there, and let's just rotate it a little bit so that it's not gonna, it's gonna have a little bit of a more exciting fall to it. Okay, so if you got this guy and you got that guy, as I said, you got actives and passives. The main difference between the active and passive is that the passive is not going to behave to fields, and if another object collides with a passive, then the passive is not going to react. Let's put it this way: if I had two of these guys and one was coming onto the other one, I'm going to go ahead and draw this. So if you had that guy and little fake cube there. Oops. Okay, you get the idea. So if we had those two, and this was heading in that direction, and that guy was heading in that direction, and this one was heavier than that one, as far as collision goes, the heavier object is going to keep its trajectory, whereas the lighter object is going to bounce back and react. That is what happens in real life. As far as actives and passives go, let's do our little drawings again. If this is an active and this is, let's just draw it out here. If this guy is active and this guy is passive, when this guy goes down and bounces there, why don't we make a little impact drawing there? There we go. So when it collides there, the passive object is going to stay there, and the active object is going to bounce back and come down and bounce back and come up and come down and so on and so forth. Okay, but this guy doesn't do anything because it's a passive body. Passive don't. It's like, you can think of it as like an extremely massive object, like a building or like the floor or like the earth. You know, it's something that's massive, so it's not really going to have any reaction to another object. Now, in the contrary, if this guy was an active and this guy was an active, then when this guy falls and collides with that guy, then that guy is going to fall, and so is this guy. Everybody falls. All right. So it's that's what happens with two active objects. Okay, so I hope that explains this. So with that in mind, let's make our cube an active rigid body. How do you make it an active rigid body? Very simple. You select it, you go to soft rigid bodies, and you say create active. How do you make a passive? Well, you select the passive and you go soft rigid bodies, create passive. And then you press play and nothing's going to happen. Whee! Why is that? That is because there is no gravity. You gotta think of Maya as the Matrix. It doesn't, you can make your own things up. So if we wanted to have gravity, then we would have to make gravity. So why don't we go ahead and start by making it just like that. Let's go fields, just make sure nothing's selected, and go fields, gravity. And then you're gonna press play and nothing's going to happen again. Whee! Why is that? That's because by default Maya won't link an object to having gravity. You actually have to make that linking yourself. So if we wanted to link this gravity to our active, we would have to open up what's called a dynamic relationships window. If you go to the window, settings window, relationship editors, dynamic relationships, you will open up that window. So you'll see your polycube there, and when you select it, because it's a dynamic body, you'll see the gravity field there, and if you check it, you'll see it's going to highlight, and then the gravity actually turns purple. And if you're seeing this in wireframe mode, when you select the gravity, the cube is going to turn purple. That means that it's influenced by the gravity. So now when you press play, something will happen, and that is that little cube will fall and it'll behave and it'll react, and then it'll just keep falling onto infinity. Okay, so that's one way to link an active rigid body to a field, and that's usually what you will be doing, but not always. Why don't we go ahead and delete our polycube, select our gravity, and delete it as well. So we're back to only the floor being a dynamic body. Let's make our another polycube there, and let's rotate it as well. And again, if we press play, nothing's going to happen because that's not a dynamic body. Now, another way that you can kill two birds with one stone is if you select the object and then go fields, gravity. So what that does is that it's going to make a gravity, is going to link the gravity to the object, and is going to make that object an active body, like so. So you can see what happens there. But again, you're not you don't necessarily need to make it that way. You can delete your gravity, you can delete your polycube, make another one, move it up, rotate it a little bit, and simply select it and say create active rigid body. And if you have it selected, you can go ahead and make a field. So it's going to make a field and link it to that object. And voila. Okay, so actives, passives. Now you can actually change the state of an active body or a passive body. Anytime an object is a dynamic body, passive or active, it'll have this little guy here that says rigid body. Now in dynamics it's very important to name everything because it can get confusing as to what's what. Because we're keeping it simple, I'm not naming anything here, but yeah, it's ideal to name it. So you have this rigid body, and that is the actual that's the guy that controls this cube. So once you have that, there's a whole bunch of attributes here, but we're gonna start by, let me just overview what each one does. If you have initial velocity, that's going to have an initial velocity. So I can have an initial velocity on the y of 5 units, and so it's going to have an initial velocity up and then fall down. That's pretty simple. You can have an initial spin. So if I have an initial spin on the, say like that, on the x, initial spin x of 10 degrees, then is going to, maybe a little bit too little, make it 100 degrees. So you can see how now it's starting to rotate because it's an initial spin. If you have then you have these three values, which is the center of mass. If you look on the wireframe, you'll see a little X inside of your cube. That is the center of mass. You can actually change that by inputting numbers or middle mouse dragging. So why don't we get crazy and put our center of mass there? So when these guys fall, its behavior, see what happens there? Because that's the center of mass, so it's being pulled from that area. So I hope that makes sense to you. I'm going to keep that at 0 though. Then you have impulse, and that is going to be constant, a constant impulse on the y, for example. So it's now like just going up constantly and just accelerating. You can see that there. And then you have the position of that impulse. So you know, that doesn't necessarily, it's going to be 0 0 0 right now, but let's see, impulse position x1 and impulse 1. You can see what happens there. See how it's impulsing from that size and then it goes back and so on. It keeps doing more impulse. So it's like something was, let's say, blowing on it from 1 unit from its center. So it'd be like around here. Okay, so you got those guys. You have spin impulse, which is the same thing but on the spin. So you can have your object have a constant impulse on whatever axis. So if you had a constant impulse of the x, let's say, then this guy's going to fall and start spinning. It's just gonna keep spinning and then just act retarded. Let's make it less, 0.1. See, that's they just keep spinning faster and faster and faster, then faster and faster and faster, and so on and so forth. But that's impulse, constant impulse on the spin. Then you have the one that I want to talk about, which is mass. I'll talk about that when I talk about that. But I'm kidding. Mass is how much mass your object has. The heavier it is, the more mass it's going to have, and the lighter it is, the less mass it's going to have. Bounciness is how much it bounces. So it can be like this. You saw how much that bounced. Or it can be like that. It is going to have no bounce. And the reason why it's still bouncing is because the floor also has that bounce value there. So if I actually select the floor, go to the rigid body, and tell the rigid body to have a bounciness of 0, then now when this falls, it's not going to bounce. It's just gonna fall down there. Then you have damping, which is sort of like how an object loses power as time goes by. That would be, for example, if you had a pendulum, then the pendulum should little by little start having less and less and less and less amount of motion. That would be what the damping would do. We can see that later in another example. You have static and dynamic friction, and that is the amount of friction that either a field, in the case of dynamic friction, or an object will have in the case of static friction. Suppose that my passive body was like this. So when this guy falls, actually I'm gonna start by telling the floor not to have any friction. So we're only talking about the friction of our cube. Now it starts falling and it's gonna start spinning, or sorry, sliding. If we increase this static friction, let's say I'm gonna take this one to 0 and that one to 0, so it's gonna slide more. See, now it's like a faster slide. Let's increase the static friction to 50. See how that's like, I don't want to slide, I don't want to slide, I don't want to slide. So that's what that static friction does. And let's increase this to 50, but I don't think we'll be able to see anything with the dynamic friction. Yeah, because that is more in regards to fields, is how it would have friction to a field, to gravity, or to wind, or whatever. So I'm just gonna keep this at 10 since I think it's kind of cool. I don't want to slide, I just want to go down. It gives you an idea. The collision layer, you can keep that at 0. You don't have to worry about that. That's just if you want to have particular objects collide with particular objects. So like two objects in 0 would react to each other. Two objects in 1 would react to each other, but it won't react to the ones that are in 0. The stand-in is a pretty handy tool when you have simple primitives, because you can have a sphere or a cube. So if I make this cube in a cube stand-in, its behavior is going to be more real, because it's just like a simplified version of the cube, so it's actually going to be very real. Sometimes when things get slow or freeze up on you, you would want to change that. And then you have the one that I was talking about, which is the active state. Right now this one has an active state of on, and the passive one has an active state of off. So whenever I make an object active, I'm going to make my floor active now. It's not linked to the gravity, see? It doesn't have any link, but it is active. So when the floor, when the cube collides with it, then this guy is going to react to that guy. See? They both go ahead and fall. Now if this had more mass, let's see if we are able, well, there's no bounciness, but we're gonna give it a shot. There you go. See how this guy is now going just really slow, because it's not, since he has more mass, is going to influence more on this than on itself. So like I said, you know, passive body is a body with like a retarded amount of mass. So instead of giving a retarded amount of mass, just make your objects passive. Particle collisions come to play once we talk about particles. You can lock the center of mass. The ignore, just keep that in off. And the collisions, you know, if that's set to off, then this guy is not going to collide, so our cube is just going to keep going. And you can apply the force at vertices or CVs, bounding box, or center of mass. So it depends how you want the force to be distributed along a surface. If it's on vertices or CVs, then the forces are being applied on those CVs rather than on the bounding box. If it's on the bounding box, then it's all around, and if it's on the center of mass, then the force is only going to be exerted on the center of the mass. So that's pretty much an overview of actives and passives. So we can actually go ahead and maybe do a little thing here. We can make another polycube and make this one higher up, and link it to our gravity field so it's active right away, they're both going to fall, and you can see what happens there. But if we give our little guy, or yeah, why don't we give our little guy, no, let's give our big guy a lot of mass. I don't know, let's say 500. That's a lot of mass. So when they fall, the big guy is going to exert more force on the little guy. And of course all this comes into play with other values. So you know, that's one way. Another way of showing you this would be if I move this guy over here, and let's unlink it from the gravity, and this guy unlink it from the gravity, and I press play, nothing's gonna happen. But when we give the little guy an initial velocity on the x of 5 units, so it's gonna go that way, and the big guy an initial velocity on the x of -5, they both have the same initial velocity. When they collide, the big guy is going to have more force exerted on the little guy. I hope that makes sense to you. But you know, you can do also like funky things. So I can make my little guy really little, and the little guy has, for example, a mass of 500, and the big guy has a mass of let's say 0.1. So now its behavior is going to be like, wait, what? wait, what? What's going on here? Why is the little guy exerting more force? It's just because he has more mass. So those are just some of the basic principles here. Again, you can always link your objects to gravity fields or any other field. So they, for example, will do that. And you can also, you have a whole bunch of fields here. You have newtons, you have gravity, drag, air, radial, turbulence, the uniform field, which is a uniform field, vortex, volume, axis, and volume curve. You know, something that's probably exciting here would be the turbulence. So yeah, this unselect. I'm going to select both of these guys and unlink them from the gravity, and so they're only linked to the turbulence. And right now they're kind of like doing that. But if we select our turbulence, let's move those guys out there. That's our turbulence right there. If I press T on the turbulence, I can see some of the attributes there. Maximum distance is set to -1, which pretty much means that there's no maximum distance. There's attenuation, which is the fall off, and then there's magnitude, which is the strength. If I press the little power button again, then I have frequency, which is the frequency of the turbulence. Now it's got a bigger frequency. And then it has a phase that you can change as well. And the last one, you can change all of them, so I can actually give it a lot of magnitude and very little attenuation, so it's got a lot of force. So you can see what's happening there. They're like, oh my god, oh my god. This guy has a turbulence field, that guy has a turbulence field. And let's decrease our frequency. You know, the guy that has more mass has less, you know, the gravity won't be exerting a lot of force onto that guy. It will be exerting a lot of force on this guy because it doesn't have a lot of mass. I'll give it a mass of 10, see if that's a little bit more behavioral. There we go. So those are some of the values that that you can play with on here, and you know, you can keep playing with them. For example, instead of a turbulence field, I can have say vortex. And of course, if there's a vortex, it would have to be linked to these guys. And again, you press T, you'll see the magnitude, attenuation, and maximum distance. You can also see the axis, and then you can see all of them. So let's pause this, go back, give both of these guys the same mass. So I'm going to give both of them a mass of 1. And you can see how they're trying to revolve around the vortex. And if we decrease the vortex attenuation, then there's a lot of force being exerted. And if we increase the magnitude, then even more. Now, if we have a negative magnitude, then it's going to go the opposite way. So these are all just some values that you can play with. And you can do the same with the Newton. For example, let's go ahead and I'm going to select both of these guys and say fields Newton. And the Newton is just some force that would attract all the objects to the Newton. So I'm actually going to put it over here a little bit so you can see, and yeah, it doesn't have any too much attenuation, too little attenuation or magnitude. So increase the magnitude and decrease the attenuation, and you can see how these guys are just trying to get on there. They're just being it's like a planet, you know, it's attracting the force to it. And just as it can attract objects to it, if the magnitude is negative, is going to make objects, you know, fly away from it. So you know, you can get a lot of cool results by playing around with fields and having multiple fields and playing with multiple attributes for all these guys. Why don't we give this guy a little bit more mass? See what happens. Isn't that cool? So yeah, that's pretty much what that does. And you know what? I want to try something. And if it doesn't work, you don't blame me for it, since I haven't tried this ever. But there's an option under fields that says you selected a source of field. So I'm going to make this guy and check you selected a source of field. Oh, I'm sorry. I'm going to make myself I'm going to select this guy, and I'm going to make myself another Newton, and I'm going to put the Newton here, and I'm going to, there we go. So there's where my Newton is. I'm just going to put it right where close to where the center of the mass is. Okay, there we go. And I'm just going to parent it. So this guy is being affected by Newton field 2. This guy is not. And I'm going to select Newton field 2. And then I'm going to shift select the big object, and I'm going to say fields. I'm sorry, I'm going to select the little field, the little guy, and then I'm going to say fields. You selected as source of field. And let's see if we actually get to have this guy behave like Earth, and then that as the moon. Let's see what happens. It's almost there. Let's give it a little bit more intensity to our Newton. Magnitude attenuation, let's take that to 0, and let's see what happens there. And magnitude 20. Isn't that cool? Well, it's flying away. So let's give it a magnitude of 500. Let's see what happens there. I don't know. Just oops, that's too much. Okay, so magnitude of 10, and this guy, let's give it less of a mass. And maybe if we increase the dynamic friction, or maybe the damping. Start with the, yeah. It's a little erratic, but at least it's rolling around my planet there. So we got a hyperbola there. So anyway, in short, you can play around with fields to get a cool effect or a whole bunch of cool effects. Oh my god, that guy's just going crazy there. But anyway, I hope you enjoyed that tutorial, and I'll see you next time. Bye-bye.